Okay, so in this video we're going to look at how to find stationary points of functions by differentiating. So here we've got a graph of a function of x, y equals f of x. And if we think about the gradient of this curve at different points, let's mark in some points. So we know that the gradient of the curve at these points is equal to the gradient of the tangent at these points. So let's just draw in the tangents to the curve at these points. Now, for our first point here, we can see that the tangent has a positive slope. The gradient is positive here. And if we think about this function at this point, this function is actually increasing. Okay, as our x value increases, our y value also increases as well. So at this point where our gradient is positive, the function is said to be increasing. Now if we consider this point, our tangent has a negative slope. And as x gets bigger, so if we think of x at this point, that's our y coordinate. If we think of x at this point, that's our y coordinate. As x gets larger, y is getting smaller. So we call this a decreasing function, and our gradient is negative. Now, at this final point here, our gradient of the tangent is equal to 0. It's a horizontal line, and it has a gradient equal to 0. Its slope is equal to 0. Now, we call this type of point a turning point, and it's also referred to as a stationary point. So at a turning point, or a stationary point, our gradient function dy over dx is equal to 0. Now we have some different types of stationary points. On the left hand side here, we've got a point which we call a maximum. As we can see, this is the maximum value of y for any value of x. We sometimes refer to this as a local maximum. For this function, it's actually the maximum value, but for a cubic function, we might have other values which are larger in other regions of the graph. And on this graph here, we have a minimum or a local minimum, because this is the minimum value of y for the given values of x. So what we can see for a maximum is that the gradient changes from being positive to equal to 0 to being negative. And for a minimum, the gradient changes from being negative to being equal to 0 to being positive. So these are two types of turning points or stationary points, a maximum and a minimum. Okay, so here we've got quite a simple function, y equals x squared plus 2, and we're going to look at how to find the stationary point for this function. Now you should know from your knowledge of graph sketching what the stationary point of this function is. This is a transformation of the graph y equals x squared, and you know the stationary point for y equals x squared. But we're going to look at how to do this through differentiation. So the gradient function of this curve, dy dx, is going to be equal to 2x. And as we said before, at stationary points, our gradient function dy dx is equal to 0. So 2x is going to be equal to 0. So obviously this implies that x is equal to 0. So our x coordinate of our stationary point is equal to 0. Now we need to find the y coordinate. To do this, we need to sub our x coordinate into our equation of the graph, which gives our relationship between the x coordinates and the y coordinates. So we're going to sub x equals 0 into our equation of the curve y equals x squared plus 2. So x equals 0, y equals 0 plus 2, which is 2. So therefore our stationary point, I'm just going to write that as SP, is x equals 0, y equals 2. We can classify our stationary points by looking at the second derivative. So our second derivative is we call d2y dx squared. At a maximum stationary point, d2y dx squared is less than 0. And at a minimum, our second derivative is greater than 0. So say we had the graph y equals x squared plus 3x minus 1, and we want to find the stationary point. Our gradient function is 2x plus 3. At stationary points, our gradient function is equal to 0, so 2x plus 3 equals 0. This implies that x is minus 3 over 2. To find our y coordinate, we need to substitute minus 3 over 2 into our equation of the curve. So when we do this, we get, let's just write that out, that x equals minus 3 over 2, y equals minus 3 over 2 squared, plus 3 times minus 3 over 2, minus 1. And if you evaluate that, you get y equals minus 13 over 4. So therefore our stationary point is minus 3 over 2, minus 13 over 4. So now we're going to find out if this is a minimum or a maximum point by looking at our second derivative. Okay, so let's first find the second derivative of this. We said dy dx, our first derivative, is 2x plus 3. So if we differentiate again, d2y dx squared is equal to 2. And we can say 2 is greater than 0. Therefore, our stationary point is a minimum. If we think about the graph of y equals x squared plus 3x minus 1, it is a positive shape parabola. So we expect that our stationary point is going to be a minimum.